One of the most common uses of multivariable calculus in applied settings is constrained optimization. So the idea here is that we want to maximize or minimize some function f of several variables subject to some constraint. So here, f, the thing that we're trying to maximize or minimize, this will be called our objective function. And then the constraint on the variables, so that's going to be, some expression of x, y, and z is constrained to be equal to blah, blah. This is the constraint. And so notice that the objective function is a function, but the constraint is actually an equation, right? And so the way this works, so what we're going to look at in this chapter anyways, is to solve, what we're going to do is rewrite this constraint by solving it for one of its variables. Right, so for example, maybe we let's say we can solve y. Say y is equal to, and then you got some expression here, and there's x's and z's and numbers and whatever else in there. Yeah. Then we substitute this into our function, and so we have f x, and then this expression that we just found, z. And so we now we've reduced it, and it's only a function of two variables, and the constraint is built in to this new function. And so in fact, we might actually rename this as some different function to indicate that it's being constrained. So this is exactly the same kind of thing that we do when we take a trace, right? So when we take a trace, what we do is we say something like, oh, I'm gonna take y equal to 2, and then I take my original function and I swap it out by substituting in 2 for y. Now what's going on here is that we might have something that's more complicated, but we can still substitute it in for y if we can solve for that variable in the given example. Right? And so now we're not necessarily looking at the value of f along some line parallel to the axes. We're looking at it on some who knows what kind of curve or surface that we obtain by reducing in this way. But this will allow us to, so if we maximize f here if we find the values of x and z that maximize this f, then we will have maximized f while making sure the constraints are satisfied because they're kind of built in there.